Yes, how are you? So, uh, welcome to this part of application of derivatives. This is motion, and simply put, we interested in looking at displacement, which is a distance that a body moves. We also interested in looking at velocity, which is speed in a given direction, and we also interested in looking at the acceleration. Now, we all know from previous experiences that whenever you're given distance, you can be able to compute. You can be able to compute speed. Say, if you have distance, you can be able to compute speed, and we usually say that speed is equals to distance divided by time. You also able to compute acceleration, which we always say is speed divided by time. Now we want to introduce derivatives to this, so we want to work with differentials. And to work with differentials is just to say, instead of just having distance, we have, I mean, distance as a number. You see here, you can have distance equals to say 30 and time say equals to 2. Okay, so instead of having distance as 30, we have it as a function. So we introduce a function s, so that we're saying that distance is t squared plus 2t, something like that. So this is basically what we want to do. And to get us started, I want us to define these three terms. So I want us to have displacement, I want us to have velocity, and I want us to have acceleration. So let S be displacement. This is a distance that a body moves. Okay. Let V be our velocity, and let small a be our acceleration. So now we can comfortably say that velocity is equals to a change in displacement. It's a change in speed divided by a change in time. Okay, and the other one is that acceleration is equals to a change in velocity divided by a change in time. And that's it. That's how derivative comes into play here. So the derivative of displacement or distance moved with respect to time is velocity. The distance, the change in velocity with respect to time is acceleration. And therefore we can pick an example here. Example, let S equals to t power 3 minus 6t squared plus 9t meters. Okay, B displacement or distance moved, B distance moved by an object where t is time in seconds. So we can find a number of things. Find one, velocity. Okay. Two, we can find velocity after. Velocity after 2 seconds. 3, we can find distance moved. No, distance moved after 2 seconds. 4, we can determine maximum. We can determine velocity acceleration. And 5, we can determine maximum acceleration. Let me also introduce maximum velocity. Number 6 is maximum velocity. Okay, so this is simple, very simple. So we can write solution here, and we start with the first one, velocity. So what is velocity? Is change in s over change in t. So derivative of s with respect to t is what? Is 3t squared minus 12t plus 9. Okay. The next question is what? Velocity after 2 seconds. So this is the first one. The second one is v after 2 seconds. So this is v is equals to 3t squared minus 12t plus 9. So the only thing that we need to do is to substitute t with a 2. So this is 3, 4 minus 12, 2 plus 9. So this is 12. 12 plus 9, plus 24. It's not plus, it's a minus. This is minus 24, then plus 9. So what is the answer? The answer is a negative 12 plus 9 should be a negative 3, and this is meters per second. This one was supposed to be meters per second because this is velocity. 3, we can compute distance moved after 2 seconds. So distance is s. So s is t power 3 minus 6t squared plus 9t. Now, the only thing that we need to do is to substitute at t equals 2. So what does it give us? This one gives us 2 power 3 is 8 minus 6 times 4 is 24 plus 9 times 2 is 18. So this is 26 minus 24. The answer is 2 meters. Okay. Question number 4. We want acceleration. Now acceleration, we've said is change in v over t. So what is v? V is 3t squared minus 12t plus 9. So derivative of this must be equals to 6t, okay, then minus 12. That is the acceleration maximum. Now anytime we talk about maximum of anything, we usually from what we have learned in maximum, minimum and all that, anytime you talk about maximum, you simply saying equate the derivative to 0. So number 5, maximum acceleration is the derivative of v, which is equals to a, with respect to t equated to 0. Now we already have this guy, and this guy is 6t minus 12. So we want to equate this to 0, and therefore the answer becomes 6. The answer becomes 6t is equals to 12, and therefore t is equals to 2 seconds. Now we interested in maximum acceleration, not the time. So maximum acceleration therefore becomes, so maximum a is equals to 6t minus 12 divided by maximum acceleration is 0. Okay, so just a minute. So we want to do what? We want to put t equals 2. So this is going to be 6 times 2 minus 12, and this one is equals to 0. So the answer is 0 meters per second square. Okay. This is according to the computation. The rationale of that, we keep that for another day. The last question, we want maximum velocity. And maximum velocity, I want to erase part of this so that we can work it out. Maximum velocity. So maximum v, maximum velocity. We have said that anytime you're looking for maximum, basically what you're doing is you want to equate the derivative to 0. So v is equals to change in s over change in t, and we want to equate this derivative to 0. So what was that derivative? V, it was 3, so you simply saying 3t squared minus 12t plus 9, that is our v, equated to 0. So at this point we have to work out what? We want to work out the quadratic, use the quadratic formula, and we all know how to use the quadratic formula. So t should be equals to a minus b, so this is 12 plus or minus the square root of b squared. 12 times 12 is what? Yes, 144. Uh-huh. 144. Then we minus 4a and then c, like this, and then we divide everything by 2 times a, which is 3. So whatever comes out of this is going to be our t, and then after we have gotten our t, we substitute back into the v to get the maximum velocity. I hope this is of help to you as you seek to get deeper into the application of derivatives, and specifically in motions. So you can you can look for more examples in books, and then try to solve them using this concept. Have a good day.